Hey, hello, my name is Chaudhary Daniel, and my group partner is Joanna Johns. Today, we're just going to talk about Gale Shapley algorithm and how it all works together. So, first, I'm just going to go over the introduction. First seen 10 years early, the propose and reject algorithm, also known as deferred acceptance algorithm, was first properly analyzed by David Gale and Lloyd Shapley in a famous paper dating back to 1962 that still stands as one of the greatest achievements in the analysis of algorithm. He has had a profound influence on economic market design and by raising new theoretical questions in various disciplines. Deferred acceptance algorithms are implemented in school choice systems in Boston and New York City and labor systems across the globe. Imagine you're owner of a dating agency that must match up N men and N women. Each man has an ordered preference list of the N women, and each woman has a similar list of the N men. Or perhaps you are in charge of National Residency Match Program, which pairs medical school graduates and residency slots at teaching hospitals. What we just described is the stable marriage problem and the residency matching problem, two problems that we can solve using the Gale-Shapley algorithm method, or how we just describe everything, how we explain everything. The Gale and Shapley algorithm involves a number of iterations of proposal, acceptance, and rejection. In each iteration, each unengaged man proposes to the most preferred woman to whom he has not yet proposed, regardless of whether the woman is already engaged. And then each woman gets engaged to the proposer she most prefers, her existing fiance or someone else, and rejects the rest. Lastly, any man who was rejected as step k-1 makes a new proposal to its most preferred acceptable mate who hasn't yet rejected him. Efficiency. The runtime complexity of this algorithm is O(n) square, where n is number of men or women. Input is a 2D matrix of size 2n into n, where n is number of women or men. Rows from n0 to n-1 represent preference lists of men, and rows from n to 2n-1 represent preference lists of women. Here is one example where I'll just show you guys how this whole algorithm works. Firstly, A proposes to his most preferable option O. As O has no better options for the time being, she accepts an A. Next, B proposes to his most preferable option P, and as she has not received any better offer, she also accepts. After that, C proposes to M, and she also accepts due to lack of any other offers. D then proposes to P. Now that P already has received a better offer from B, so she rejects D. Finally, E proposes to O, but as O has already received a better offer from A, she turns him down. At this point, both A, B, and C are already engaged, so do not attempt any more proposals. D still has no partner, so proposes to his next most preferable choice, who has not rejected him. M. M prefers D to her previous offer from C, so she dumps C and is now engaged to D. E proposes to L, and as she has not received any other offers, she accepts C. Now, the only man who has not yet to find a partner after being dumped by M, he proposes to P, then L, then O, just turned down by all three as they have better options. Finally, he proposes to N, who accepts as she has not received any offers. Thus far, all the males are now engaged, and as there is no need of any more proposals, we are done.
I'm Joanna, and I'll be showcasing how the code works for this algorithm. Right here, we're defining our men and women list, and we're using the pandas data frame to store the values of preferences. Woman underscore df is printing out the women's preference list, and men underscore df is printing out the men's data frame. Once we establish the data frames and preferences, we can get started on the Gale-Shapley algorithm. First, we're going to use the dictionary to control which woman and which man can make a proposal to one another, and then another dictionary to store the creative pairs, and a variable to count the number of iterations. We are seeing how many iterations it takes to create a stable marriage for this problem. We have a while loop here that looks at the man's proposal and then takes each proposal to the top of their preference list of the woman. And if the woman has more than one proposal, then she will choose the best option out of the proposals that she has received from the men, and this will lay the foundation for, let's say, if a woman were to accept a proposal from her third option, then receives a later proposal from her first option, this will allow the algorithm to reject the third rejection that she is already engaged to and then move on to a better suited proposal that is higher up in her preference list. If a man was rejected by a woman, then there isn't any additional room for him to make a proposal, and he will just go through his list until he runs out of women on it. Then it will call the proposals and it will count and print out all the iterations that we just went through. And then here are the tables for it, along with the rest of the code. And here are the stable pairs, and that's about it.